We start now session 2 of today's summit. Mr. Stavros Hatzigrigoriou will be the panelist. Mr. Hatzigrigoriou, the moderator, my apologies. Mr. Hatzigrigoriou, you have the floor.
Thank you. Good morning, Kalimera to everybody. I will not say anything in the beginning because the key topics for this panel, it's a bit of, I don't know how to call it, Russian salad, tzatziki, something like that. There is a small presentation from Mr. Kim from Korean Register. I will let him do his presentation. You can go there. And then I will ask the panelists questions. Each panelist will have about 3 minutes to reply. I'm not going to interrupt them, but please keep the time. And I want to leave some more time for questions at the end.
Yeah, good morning, everyone. My name is Sang Hyuk from Korean Register. I'm a senior researcher, and I'm living in Busan headquarters. So it's a really big honor to be on panel on such kind of large discussion. And before our discussion, I would like to share our experience about the performance analysis for the decarbonization. I believe that the economic operation is the first step at the foundation of greener shipping. So I will share about what I learned about the analysis. So I believe that this can be bridged the gap between the operational data and the ship owners' rational decision making. Let me start my presentation. So first, I would like to say about the data. We already talked a lot in the previous sessions. So generally, ship owners provide us data generally about 3 kinds of data. First one is annual report data. This is the fundamental for the IMO DCS. But such kind of annual data is using such kind of data, we can see some general trend of what I have and what other ships have. But in order to see more details for my ships, at least NUNLAB data is required. And in my opinion, high-frequency operational data is the gold standard. So today, I will focus on the performance analysis procedure based on the high-frequency operational data. So the most important relationship in the performance analysis is speed versus power. So in our analysis, we assume that the measured total power is influenced by the 4 factors. First one is the baseline and performance degradation and weather effect and operational effect. So measured data includes those 4 factors. And also performance degradation includes the inherent aging and also some manageable vectors such as hull fouling and propeller cavitation. So using the data, we try to quantify those 4 factors in the measured data. But in such kind of, it looks like very simple in such kind of simple diagram, but it requires very complex procedures and technical know-how in order to distinguish those 4 factors. At the moment, we use physics, but we are trying to, I'm in the middle of project to use the AI in order to figure out what happens in the measured data. So I will talk about some things related to performance degradation. As you can see in the figure below, this one, this is raw data. The x-axis means the ship speed and y-axis means shaft power. And this is data for single ships from 5 hours period. And different color means each voyage. As you can see here, raw data is very extremely scattered and it's very difficult to figure it out. But figure changes very dramatically after we use steady state filtering and remove all the weather effect, operational effect. After that, we can identify some trend of performance degradation. So we can, based on this filtered and processed results, we can set our baseline and see the trend of performance degradation. In our experience, we did some case study for 12 sister ships for 24K container ships. We found that about 1.5 to 2.5 of annual performance degradation was observed. I have to say that this is for well-managed ship. This kind of performance degradation can even worse. Then let's talk about weather and trim effect. I will brought some example how weather affect on your speed power performance rather than explain the whole detailed procedure to quantify the weather effect. So as you can see here, I also brought some speed and power performance graph. The points upward means you require more power in order to bring your speed. As you can easily think, headwind condition shows more power rather than tailwind condition. The similar trend can be observed in your wave effect too. Head sea condition requires more power than the following sea condition. Also, large trim induce more power rather than even trim condition. So I will also brought some example of rudder effect. So I will brought some movie example of our interaction dashboard. As you can see in the graph, larger rudder angle does not show the general speed power performance line. So our interaction dashboard, if you select the larger rudder angle area, the system automatically filtered out all other parameters and see what happens when the larger rudder angle was activated. So this is the other time history of speed, the wave height, wind speed, and speed power condition. And using such kind of dashboard, we can figure out what happens when the larger rudder angles occur, and also where it happens. As you can see, here highlighted, the blue highlighted one, the larger rudder angles happen near the port and shore side. So previously I talked about speed and power performance. Besides speed and power performance, the engine efficiency is one of the most important factors in the analysis. So as you all know, engines rarely follow their design manuals in real-world conditions. Even with the identical sister ships, real engine efficiency can vary, real engine efficiency can show significant discrepancy. So I brought some example of two sister ships engine efficiency results. As you can see here, so the blue one is measured one, and the yellow one is the baseline spec. So you can see that general trends are very scattered measured data trend, and there is some offset from the baseline. Especially for the high power range, there is some significant discrepancy between the two ships. So such kind of engine efficiency should be independently figured it out rather than the speed and power performance. After that, we can distinguish where energy losses are from. I mean the hull side or engine side. So after such kind of decomposition, we can break down how our fuel was spent, distinguish between the technical performance or operational variables. Such kind of diagnosis tells us that we need to schedule the hull cleaning now or not, and how should we have to revise our speed profile for more economic operation or not. In a similar manner, such kind of analysis and performance analysis results provide some solid foundation for our CII strategy. So in all this, in order to support our ship owners' data-driven management, KL developed some web-based platform. So it enables visualize operational histories in a statistical manner, and also analyze, as I said, explained before, analyze ship's performance, technical performance, and break down a fuel consumption contribution, and also provide some simulation functions for operational profile change. So we are in full service of phase 1, and phase 2 will, the performance analysis and virtual simulation will be launched at the end of this year. So you can see the Power Page 1, which is in full service. You can visualize your all fleet, the KL class fleet. So you can see some fuel consumption status and CII status, and also you can compare your classed ships for several ships, speed profile, draft profile, or experienced weather profile. In a conclusion, the paradigm shift from the experience-based to data-driven decision-making, intuitive route planning to optimal route planning, heuristic speed control to performance-linked speed control, and qualitative verification to quantitative verification. Also in individual silos governance to standardized intelligence. So we always say that more data with good quality will support for better decisions. Thank you.
Thank you very much for the presentation. I hope the data was not coming from noon reports. Yes or no? I have a question for you, Mr. Kim. Yes. Normally, when a new ship is to be designed, we have a 15% C margin. Yes. For the conventional ships, and we have a 20-21% C margin for PCTCs and LNG carriers. A few years ago, we did a study with Korean Register, and it was in a way confirmed that over a year, the 15% C margin for a VLCC was okay. What is your opinion? What is the comparison of design stage estimates and real life?
Yeah, thank you for your question. I think it's the performance gap between the design stage and the performance in real sea is a very important issue because it is directly related to the profit. Actually, we have to admit that there is the gap between design stage and real sea operation. One of the big differences is the ship's current condition and the noise, which is bring from the weather effect and operational effect. So the most important thing is we need to figure out how the real sea's technical performance are developing and figure out how to quantify our weather effect. And we have to admit that there is some performance degradation. And current our technical performance is different from what the ship is delivered. So we have to need to perform very sensitive and systematic analysis in order to figure out the difference between the design state performance and real sea performance.
Just one detail to be discussed. Do you propose to the ship owners to keep the 15% or 20% margin for themselves, where they describe a ship, or split it between a charter party description and the performance of what we have from sea trials?
Actually, in a real sea, we can experience more than sea margin, but we have to. It depends on how you manage your ships, I think. Yeah. So we need to separate the design performance and real sea performance and expectation of how you feel about your fuel consumption.
the expectation is what we have in the charter parties. It's not the design performance.
Sorry.
When you describe a ship to give it out for business, you have to give to the charterers speed and consumption numbers. I know many cases that owners have given to the charterers the sea trial description, and then they start losing money from day one. This is my question.
Yeah, for charter, you have to know the real, true technical performance of your ship in that moment, not the design or delivery condition. So in order to do that, we have, as I said, you have to figure out your operational data and find the true speed power performance or speed fuel performance of this time. And then you can manage your speed profile or route planning and etc. So it's very important.
What you had in your presentation was a degradation of 1.5 to 2.5% a year. So this should be taken into account.
Yeah, but also, as I said, the 1.5 to 2.5% of performance degradation is based on the operational performance analysis from the operational data, not the design's evaluation.
Thank you very much. Second question is for Mr. Kartibelis. If you can say just a few lines what carbon capture is, because many of the people from the audience may not know.
Okay, it's the million-dollar question in a few lines.
Okay.
I'll try that. Okay.
No, but the real question is what are the issues that are preventing the implementation of carbon capture, at least today?
Okay. In order to reply that, one of the major issues that we have currently as the shipping industry is that we don't know what will be the future fuel used. So investing in a carbon capture technology, which is a huge capital expense for the owner, would require that knowledge. Otherwise, it will not make any sense to us. Now, the technology, as we know, from the land industry mainly, is there. And it is increasingly going towards to the implementation in the shipping industry. The decision is a different matter. We don't have to discuss this right now because it will come in the near future where we go directly to the net zero carbon emissions. The real challenge in the problem is not only the investment that needs to come from the ship owner, means the infrastructure technology and all that will be implemented. It's the port and the availability from the shore industry to get rid of the elements that are produced from the carbon capture, which means that the vessel, okay, if we imagine that we do have the capability of running the project and invest on that, it will produce some contaminants. At this moment, there is no investment on the land industry for transportational and exposure of the contaminants that are coming out from a carbon capture technology. So it is a collaboration. It is something that everybody needs to be aligned, the shore industry and the shipping industry, in order for this technology to become feasible, available, and economic available for the future.
So the main issues is the cost of the technology?
The cost of the technology for the ship owner and the cost of the technology and the installation on the shore industry.
You mean the infrastructure to
Yes,
collect
the infrastructure to collect the contaminants,
CO2.
yes.
Thank you very much.
Thank you.
Thodori, I'll ask the second question first. What we see today in the new building market is the shipyards insisting you have to order a repeat. If you don't order a repeat, you lose the berth, you cannot order, which is not in line with all this discussion about new technology, zero carbon, and all the rest. Ajax in the past, they have said, and they have a requirement, that you cannot, the maximum time that you can have for the declaration of an optional vessel is 1 year. Do you think that something similar should be applied for the new designs? 1 year and then we need a new design? Don't say yes.
If I said yes, then the conversation would be over. Thank you, Mr. Hatzigrigouris, and thanks to everyone attending this interesting panel. Yes, Theo Courbelis, Lloyd's Register, tanker segment. So, to start with a few thoughts on your question, if we go back to 2008 and do an analysis on what current designs have achieved without necessarily alternative fuel options, the results would be impressive. So, just to give you an idea, we have done an analysis for tanker design, starting from 50K MR tankers, moving up to VLCCs from anonymized DCS data with samples over 200 vessels per category. And we tried to understand the improvement in fuel consumption per ton mile. So the results over 20 years' time or 15 years' time were impressive. A significant reduction, more than the anticipated reduction schemes and reduction trajectories as set out in the IMO. So the industry is self-regulated. EEDI, as you all know, and you mentioned it, is a design index. It has nothing to do with the actual performance of the vessel or the actual fuel consumption. The same stands for CII, where two sister vessels, if put in different trade routes, they could have extremely different results in their CII rating. So if we are pragmatic, the shipbuilding industry and the operators themselves have done excellent steps towards reducing the carbon footprint of the vessels. When it comes to the actual design and sister ship consideration, we do see that today that we are in a shipbuilders market, and the shipbuilders are mandating repeat designs. Maybe yourselves, you have seen it in New Hantong recently with the VLCC design. Other yards are doing it as well. It is evident that the yards are not promoting their latest designs, not to disrupt their production schedules. As far as Ajax is concerned, the only thing that comes into our mind and into our remit when it is related to a pre-existing or pre-approved design, when it is to be approved from another classification society, is the recent application of Ajax PR42 about the refreshment of plan approval with respect to updated rules. But statutory-wise, there is no change for the consideration of sister ships, and I do not believe that the builders have any intention on frequently updating their designs, especially in today's market.
Because we have owners that are ordering ships in dozens, not one or two. You want to say something? Okay. Say it now. Yeah, the solution, Nico and Thodori, is to upgrade the EEDI. If the EEDI is upgraded, they have to do certain changes. How much? I don't know. How much they will cost? Again, I don't know.
But if you upgrade the EEDI, the major effect will not be in the hull form, will be in the engine.
Not my problem.
But generally, most of the designs today, I think I can speak for tanker designs, more than 90% of the tanker designs has been offered at EEDI 3. And
Compulsory.
it's compulsory. And we don't see soon enough. Μόνο του κλείνει. I don't think that soon enough we will see, at least for the deep sea vessels and the CSR vessels, EDI-4.
Yes, but we have paints, we have wind propulsion, we have the engine room, as you know. I mean, very few yards are offering VFDs as their standard design. We can go a bit forward, but it's up to Mr. Trump to decide. I don't know. Mr. Michas, I think you have spent a lot of time discussing new fuels. What do you think will happen in October? You think that the discussion about new fuels will continue, or we will have to start from zero, as the US are asking for?
Okay. Thank you, Nikos Michas, Rina. Thank you for the invitation. Yes, correct. I mean, it's a surprise for me. I was watching one webinar last week, and again, Maes was talking about methanol, ammonia, and as we have seen, these green fuels does not exist, and we cannot bring them in the market the next years. Because all the renewable energy we use, we can take maybe 3% of the fuel needs we need around the world. So definitely we will see something from IMO. I mean, the postponement of GFI does not mean, I think, that we will not have something, but it has to be something different. Because if not, we don't have some IMO, we have somewhere else. But it looks like that for the following years, except from normal fuel and LNG, we don't have something else. Not even nuclear that some of our friends are promoting. I don't see it in the next 10 years. So the question that our clients need is what we need today and not what we will have in 10, 15, 20 years. The problem is that the geopolitical events really affect fuel prices. We have seen what happened the last weeks. The same happened also with the war in Ukraine. So we expect that we will have an update GFI proposal. And of course, Trump still don't like for this. For other fuels, I don't see it for the following year. So we have to find another ways to reduce our emissions. Thank you.
Thank you very much. The next question is for George. And the question is, we have seen recently that the number of new orders for dual fuel ships have dropped a lot. We have seen companies that were pledging before last October that they will only build dual fuel ships. Now they are changing and they are building single fuel. How do you see the market to be developing? And this is also based, if you can answer it, on the relevant cost of fuels. Before the war in Iran, I mean, the cost of burning LNG was cheaper than the cost of burning heavy fuel.
Yes, actually, Stavros, with the current situation, it's extremely difficult to predict anything about cost. Yes, sorry. My name is George Properantzakis. I'm the technical manager in Dynacom. The cost is something that we cannot predict right now. After the recent events, everything has been sky high and the prices have exploded, actually. So we are a little bit on unknown ground on the matter of cost. However, the trends, at least for the fuels that we are, let's say, planning to use, it's more straightforward in the sense that we know that technology is advancing faster than the actual market. So the availability of the fuels is the most critical factor in this question. Right now, most of the dual fuel vessels being built are actually based on LNG. This is something that is obvious because dual fuel LNG is a mature technology, and the network of supply is more or less there. However, still this technology can be considered as a bridge level technology in the sense that eventually this is still a carbon producing fuel, and if regulations go ahead, it will be for a limited time in the future. Not so limited in our terms, but at least in the 2050 plan, it's a technology that will mature quite reasonably quick. On the other hand, the biofuels, it's another technology which is very interesting because it can be used right away. Of course, the cost is higher. There is a big, let's say, effort from charterers, from fuel suppliers to establish the market and have biodiesels available for the majority of the fleet. It's the most reasonable, let's say, solution. It gives you the possibility to have a direct and immediate result in reducing your at least CO2 emissions on the level of regulations. Then you have some other niche products, fuels like LPG, which is actually used only on main engines and is used only on LPG vessels. So it's a niche market. We cannot consider this as a solution for the majority of the fleet. And then we have methanol, which is it's a candidate that has been supported by a lot of decision makers for the future. The technology is not so complicated, so it's attractive because it's less complicated. Nevertheless, the challenges are there. The quantities produced, the availability of the fuel in the market are all these parameters that we have to consider and eventually have to be dealt with. The issue that we have is that, unfortunately, the situation that we have today politically is delaying the development of all these fuels. Investors are very reluctant to go ahead and invest the large sums of money as before. So we have to maintain a vigilant eye and see how the international market and the industry will go forward. And then at the end, we have a number of fuels that also are considered, but these are zero carbon fuels, which are currently, we have ammonia, for example, as a consideration, but is being delayed in all levels, development plans, facilities, networks. And with the current situation also, this solution gets more and more far away from the, let's say, everyday user. But eventually, we will have to go, in the far future, we will have to go to a non-carbon solution. So I think this is more or less what we can see right now. And hopefully we will have a more clear picture in the future about the cost involved on all these different solutions, because right now it's a little bit of a mess.
Ευχαριστώ, Γιώργο. We go back to Mr. Kim. This is something that was discussed in the previous panel. There were disagreements, but never mind. What is your feeling on the importance of high-frequency data and data that is transmitted directly to the office directly by the sensors? You don't have somebody manipulating the data on board.
So in our experience, our customers are now realizing the importance of the data, and not only the non-report and high frequency. So establishing the acquiring a system of high frequency data is first step, and the more important is maintain the acquired data as a high quality. So they are now focusing on managing the high quality data, not just acquired measurements data. Also, in terms of a null report, it can be also very useful for certain kind of purpose. Let's say about evaluate the energy saving devices. Let's talk about the air lubrication system and window assisted propulsion system. For a air lubrication system, it does not depend on the weather conditions. So if you operate in a calm condition, I mean steady state condition, null report data, I mean the one data for one single day can be enough to figure out the effectiveness of air lubrication system. At least we acquire a long enough data. But in case of the window assisted propulsion system, weather changes very much and very frequently change. So in that case, null report data is not enough to figure out the real effect of energy saving device, I mean WAPs. So in that manner, it is mandatory to establish the measurement system of high frequency data, and also you have to manage the quality of the high frequency data in order to figure out the influence of the window WAPs system. So in KL, we also make some procedure for evaluation method related to energy saving device in terms of high frequency data or null reported data, or even in the design stage. Yeah, thank you.
Thank you very much. Back to Mr. Kartibelis. There is a discussion going on about the use of shore-based power. They call it AMP, and there are several problems there. I mean, the EU has said that at least for container ships, there must be something in place by 2030. California is already applying it. The problem that I see discussing new building specification is that it is not clear what the voltage will be. Will it be 6.6 kilovolt or will it be 11 kilovolt? I'm not asking for an answer, just your view.
Okay. We do not see, and I personally do not see any technology risk in such installations. We actually been using shore power connection for the vessels during the life cycle of the vessel and the dry docking. So the technology is there, it exists. Okay, might not be able to get the full energy that it is required for operational matters, but small rectifications, or even when you order from new buildings direct installations for shore power supply, it's not a big issue for the vessel and the operators, I mean the crew on board. It's something that we currently do, and it will work out. Yes, I agree with you, Mr. Hadjigrigoris, that there is no clear rule or guideline, especially in the new builds, of what is to be used and how it is to be used. This needs to be well clarified before we go ahead and we do any modification or any rectification on board our vessels. The other problem that we foresee, it's not, if we exclude the technology risk, is the commercial risk. Are the ports ready to provide such energy demands? No. This is the biggest challenge for us for the moment, because let's do not forget that having a vessel in full operation, it requires the amount of energy that is required from a small town. So having big ports, especially in Europe, where we have multiple vessels, it would require huge amount of energy in order to supply all the vessel with shore power. The problem there lies of how do we upgrade the ports, and this is not up to the ship owners. It's definitely a public or a private sector that needs to take the first step and decides how to do it. And also, all the ports at the current moment, they are very congested. So finding the space, finding the grid lines, finding the transformers, finding all that, and install it at the port in order to provide shore power to the vessels would be a huge challenge for the port and not for us. So honestly, I believe it is a good solution for the owner, but it's not a good solution for the country. And the country definitely needs to get involved into this situation. It yet to be confirmed, the fuel EU is tending towards that way. But it's not only EU that has ports, it's global-wise, so it has to be a global guideline, a global rule of what we can install on board the vessels and what we can receive from the shore industry.
Yes, but if you don't install, first of all, there is a possibility that the port will not be able, even if the infrastructure is there, will not be able to supply the power because it's summer, because a lot of air conditioning equipment is working. But what they do in California is that they bring a barge alongside, they connect to the exhaust system, and they are supposed to treat the exhaust. And this, the latest cost that I knew for a container ship was $60,000-$70,000 per call. So there are other solutions, but let's see.
Energy competition will always be, and as we move forward to the future, energy competition will go greater and greater. Thanks to Mr. Schwarzenegger for the idea of cold ironing, I think is that. Is it workable? I don't know.
The problem is the EU followed. It's not Schwarzenegger, okay. He's Austrian.
He started,
He's
yes.
Austrian, okay. Theo, you want to say a word about AMP?
Yes. So, Vangelis was spot on the infrastructure side and the challenges. There has been a study conducted especially for Greece by ADMIE on how to bring high voltage and relevant power levels to the port of Piraeus. And only the cable work and need to dig underground and disrupt all the city planning was in the order of 70 million, just for the cable work and the infrastructure city planning. So the port side of things, in places that we have had already specific planning for ports and power needs, is a challenge. However, we have not solved yet our challenges with the ship side or the interconnection. One of the issues that is currently not mandated into IEC and ISO 8005-123 is the issue of cable reach. You need to do a cable reach study. This is what we did with Capital on their Suezmax design to be compatible with the Port of Long Beach Marathon Petroleum Terminal. You needed a crane reach compatibility study to understand where actually to place the equipment. On the tanker side, OKIMF is doing work to update their AMP guidelines, mostly related to aspects having to do with explosion-proof equipment and hazardous areas. And finally, another challenge about the dual-fuel vessels, and this is food for thought, and I'm not speaking about vessels that have Type C tanks where boil-off-gas management is better. I'm speaking about container ships in particular that have membrane tanks, and from 2030 they will be asked to plug in. So how will they manage their boil-off gas? And this would be a disadvantage for the vessel operator that have invested in the dual-fuel technology.
Yes, but if you arrive in port with low pressure, you have quite a lot of time for the pressure to go up. The latest LNG designs that I have seen, they can stay for 24 days without having to send anything to the GCU. So I think it's also an you are right, but this is also an operational issue. Okay, and since you started talking, which do you think is the ship type that is more easy to improve the efficiency?
Unfortunately, I don't have the answer for that. But what I can say is that each ship type, based on trading profile and operational issues that you have mentioned, can do specific things, meaning that vessels, bulk carriers and tankers specifically, they have, I said it in my previous position, that the bulk carriers and tankers have gone already a long way to improve their emissions. There was a study subcontracted by a company, a research company by IMO, that demonstrated that it's only like a very small portion of shipping that contributes to more than 50% of global shipping emissions. So
The big ships.
the big ships and the ships that are going fast. Because if you go 10, 11 knots laden and 13 knots ballast, and I'm not speaking about war time that we now saw VLCCs running on 16 knots. When you already go at economic speeds, you save a lot of fuel, therefore you save a lot of emissions. The thing is that dual fuel technologies, specifically in smaller sizes, they are not feasible in terms of money, in terms of if the investment will pay off. So this is a discussion that the charterers may need to be brought in, because when the charterer gets the benefit from the most new technology or environmentally friendly technology, needs to pay or to split the benefit in terms of a premium. And this can be easily seen in big vessels like a VLCC, where the dual fuel solution will cost you extra 30 million, that you need to have a premium in the charter rate that will correspond to the benefit provided for the dual fuel solution. What we have seen recently, because your question was about ship types and technologies that improve their profile, and I was not a big believer in the beginning, but now I have started changing my mind, is wind-assisted propulsion. Maybe you disagree, but,
No, I fully agree.
but I saw some, I was in Norway like 1 week ago, and I spoke with a company that have invested a lot into sales, and I saw their actual performance data into super segregator chemical tankers, and the results were impressive. So with the right route, the right trading profile, wind technology is something. I think that ESDs that are now part of the basic package in all new buildings are helping also. And dual fuel may be on a case by case, if it's related to a charter requirement or something. But at this moment, as you asked, I don't know if it was George or Vangelis, the numbers in new building orders of dual fuel ships have dropped dramatically since October.
60%. Okay, but what has not been exhausted in terms of, sorry, Nico?
The numbers in this new buildings orders have grown dramatically, but you have to take into account that there are not fewer slots available also. So,
But there are no,
just that we are not ordering dual fuel ships because we don't want to order the dual fuel ships. On our side, we continue ordering containers in dual fuel, but for tankers, when you compare it with 15 VLCCs in tanker league, there is no any slot available.
but there are no slots in general.
There are no slots in general for dual fuel ships. This is a key fact.
And there will be fewer slots now with the damage that happened.
And also another comment about the fuel that you mentioned before. I will not be surprised in the next couple of weeks, we see in some parts of the world having very attractive LNG bunkering price.
They already
So we
have.
have positioned that for our European tankers.
Malaysia is one of the ports that is offering very low.
How much inflation? That's a very good number.
It was cheaper before the war. Now what happens, who knows? But what has not been exhausted, I think, it is the size and the speed of the ships. Because VLCCs have remained the same for 30 years, more or less, same dimensions,
The
basically.
dimensions do not change. It's
Okay.
mostly related to terminal
So
restrictions.
there was a study done by the European Union, and Euronav was taking part in it, if I remember it correct. And the result was that if we built 450,000 deadweight VLCCs with a speed of 7.5 and 8 knots, emissions will go back, down 50% in one step. So this has not been exhausted. And my view on this is that, okay, the ports will say we don't have the draft, we don't have the infrastructure. If we talk about global emissions, the ports have to contribute. I mean, dredging a channel is not the end of the world, but there is resistance. Okay.
But Stavros, is this ordering of conventional fuels will lead to a big number of retrofits? You see, I mean,
No.
it looks maybe in 10 years from now, if we know where we are going from fuel, a lot of people plan to make a retrofit. Of course, a retrofit is hugely expensive. If we have not thought this from earlier.
Today we have seen only 2 methanol conversions, and we have seen 1 LNG conversion. And more.
No. First methanol conversion was co-founded by the EU with 13
But
million.
it has to. We need to have different designs. I mean, it may be hybrid designs that the retrofit will be easier.
Conversions, Nico, it's conversions. Conversion. I mean, Maersk that did the methanol conversion, they added a section in the middle where they placed the tanks, and the ships have sailed and they are not using
Because
methanol.
if you order a ship today, you take in the, let's say 2050, it will be 20 years. I mean, maybe after the 10 years of life,
but
the
this is-
taxation will be huge. So maybe it will make sense if the
But on
price
the
is
other
different.
hand, the existing ships, they become older.
Yeah.
If we do nothing for 5 years, the 10-year-old vessel will become 15.
Yeah.
And then the owners will say, better scrap it because the technology has also advanced than do a very expensive conversion. But it's not my
But this,
decision.
okay, conversion will be for a vessel maybe 5 years maximum, 10.
5 years, it's better to build it from now. Okay. So I think you almost answered the...
One thing, before we talk
The
about the
next question
fuels,
that I had to-
we talk about fuels before. We always talk about CO2 emissions, and we don't talk about other toxic emissions. But for methanol, for example, have formaldehyde and others. And I don't know why we focus so much in CO2, and we don't see some other alternative fuels that have some emissions that are worse than what is CO2. But
If you
this
ask,
is another question.
if you ask Panos Zachariadis, he will tell you that all new fuels are a bit of a disaster. But I don't know if it is or not. Last question to Paul, to George Paul. Cost of fuels. How do you think that this will develop? Cost of new fuels, not cost of
Cost of?
cost of new fuels.
Of new fuels.
There are people that are saying ammonia will be the solution. As you know, there are 3 ammonia ships that will be delivered within the next, 2-3 months. So we will get some experience. But everybody, a lot of people are saying ammonia will be the best solution to...
The cost of fuels actually will depend, first of all, on the production cost, which is evident. Any green fuel is more expensive than gray or black fuel. And then will be also a cost of transportation, because you need to make a network of supply around the world in order to support this fuel. So you need to make this network, and this network actually for these fuels does not exist. So there is an additional cost there that has to be absorbed by the market. It's a little bit hard to predict, as we said before. Right now, the conditions are changing every day. We hope that this will be something temporary, but nevertheless, the cost of fuel in general has increased with a significant multiplier. So everything is going to be more expensive. I believe that for the short-term solution, biofuels will be a solution to look for. Oil majors are already taking a position. They are trying to enforce the use of biofuels through charter parties. They are providing sufficient supply in certain areas, geographical areas, and they are doing an effort to at least establish biofuels as a reliable and sound alternative to the current fuels. This is a solution that will be it's easily acceptable by the market since there is no large modification or any at all. The rest of the fuels, especially the fuels that are carbon-free, are very expensive, and unfortunately, due to the whole situation of the regulatory matters, particularly with the position of the US now, things are getting stalled. So investors are not willing to take the jump and leap of faith and start develop new projects as eagerly as before. So this is an issue that will trouble the industry for the next at least 3 years with this administration, I believe. But everybody in this bunker or fuel market is evaluating their advantages, disadvantages, and I believe they will take the necessary position. But we are living in quite uncertain times, at least for regulatory issues.
Okay, and last question to you again.
Yes.
From the panel. The rest we can have questions from the floor. How valuable is all this discussion about having vessels LNG ready, methanol ready, ammonia ready? Is it a real advantage, or it's just a kind of advertising exercise?
Always to have an option, the option has a cost and a benefit. Having no option is less, let's say, advantage than having an option. You always need to have a plan B and be able to continue.
Yes, but the cost of having this option is maybe a few $100, and the cost of doing the thing is maybe above $10 million. So
yes, correct. But on the other hand, if you have, a plan is the first big step. So without a plan, you cannot do anything. If you have no space, if you have no, let's say, arrangements readily to be readily modified, then you are in a worst case. So I believe that depending on the commercial issues, all these possibilities are positive at the end.
What I can tell you is that in Maran we had the VLCC LNG ready in 2016, and now Sinocor is buying the ships.
Yes, correct.
Thank you. I thank all the panelists. Questions from the floor, Mr. Tseretopoulos? No? Strange. Okay, next.
Hear me? My name is Zacharias Klados from Selma Control. We are specialized on intervention retrofit on variable frequency drives with application on wind-assisted propulsion for an ME marine and auxiliary machinery. My question is the following, because we are always observing that what are the new technology on the retrofit concept of the ships, and no one is speaking about the shaft generator. Of course, this is an outdated technology, But recently we saw on some retrofit that we have participated significant results of saving. The reason is that is this outdated technology or there are any limitation on the present marine industry?
I think self-generator is getting popular now. It's coming back in a lot of designs that support self-generator. I don't think now nobody talks. I think a lot of people talking about this.
You cannot get the EDI on LPG vessels and on PCTCs unless you have a shaft generator. But do not, and as Nico said, there are a lot of companies that are now retrofitting, especially Chinese companies. Europeans are a bit more conservative. But the money, talking about money, what you get if you install a shaft generator, what you realize is about 25%, 22 to 25% of your electricity bill, fuel for electricity, and of course you reduce the cost of maintenance of your diesel generators. But we have to be careful because most of the retrofits that I have seen and most of the new buildings, they are not, they cannot use the full load for the shaft generators at NCR power. So if you want to go NCR and NCR speed, design speed, you have to reduce the load on the shaft generator. So you lose something there. And of course, if you have to run in parallel a diesel generator with a shaft generator, you have to be careful how much load you have on the diesel generator. If it is 30%, you destroy your generator. Next. Any thoughts, late thoughts? You know, but you know what the problem with Ajax is? It has to be a unanimous decision, correct? So. Reina will support. No, I think the solution there, Nico, is update the EDI. Okay, θέλουμε. Next question, or last question, up to you. Dean, still no question? Strange. Okay. Thank you, everybody. I thank all the panelists. Thank you, Mr. Kim, for coming from Korea for this. And let's break and continue later.
Coffee time.